Our stellar haven, the Sun as we know it. The Sun, a blazing ball of plasma, reigns supreme in our solar system. It bathes us in light and warmth, providing the energy essential for life on Earth. We currently enjoy the Sun in its yellow dwarf phase, a period of stellar stability that has lasted billions of years. During this phase, the Sun diligently fuses hydrogen into helium in its core, a process that releases the energy radiating outward into the solar system. This nuclear fusion is the engine that drives the Sun's brilliance and makes it the celestial anchor around which our planet revolves. The Sun's current state, however, is not permanent. Like all stars, it has a life cycle, and its journey will eventually lead it down a path of dramatic transformation. The yellow dwarf phase, while long-lasting, is but one chapter in the Sun's fascinating story. As we delve deeper into the Sun's future, we uncover a tale of expansion, transformation, and ultimately, a fading into the cosmic twilight. The hydrogen clock counting down to a giant transformation. Deep within the Sun's core, a cosmic clock is ticking. With each passing moment, the Sun converts vast quantities of hydrogen into helium. This nuclear fusion is the lifeblood of the Sun, fueling its energy production and maintaining its stability. However, the Sun's hydrogen reserves are finite. As the Sun continues to consume its hydrogen fuel, a profound shift in its structure and behavior becomes inevitable. In approximately 5 billion years, the Sun will reach a critical turning point. Its core, depleted of hydrogen, will no longer be able to sustain the same level of nuclear fusion. The delicate balance between gravity and outward pressure will be disrupted, and the Sun will embark on a new phase of its stellar evolution. This transition will have profound implications for the entire solar system, including our own planet Earth. The red giant rises, a new era for the solar system. As the Sun's core runs low on hydrogen, its outer layers will begin to expand outward, engulfing the inner planets. This expansion will mark the Sun's transformation into a red giant, a star significantly larger and cooler than its current form. The once familiar yellow hue will give way to a reddish glow, a visual testament to the dramatic changes taking place within the star's core. Mercury, the closest planet to the Sun, will be the first to experience the consequences of this stellar expansion. Venus, shrouded in its thick atmosphere, will soon follow. The fate of Earth, however, remains less certain. Some models suggest that Earth too will be swallowed by the expanding red giant Sun, its surface scorched and its atmosphere stripped away. Other models propose that Earth might narrowly escape engulfment, but its proximity to the red giant Sun would render it uninhabitable. Section 4. Earth's uncertain fate. Engulfment or distant witness. The question of whether Earth will be engulfed by the red giant Sun or survive as a scorched and barren world remains a topic of scientific debate. The outcome hinges on a complex interplay of factors, including the Sun's exact rate of expansion, the loss of mass from the Sun's outer layers, and the gravitational interactions between the Sun and its planets. If Earth does escape direct engulfment, it will nonetheless face a bleak future. The intense heat and radiation from the red giant Sun would evaporate Earth's oceans, leaving behind a desolate and lifeless wasteland. The once vibrant biosphere that characterizes our planet would be extinguished, leaving behind only faint traces of a world that once teemed with life. Section 5. A cosmic farewell. The planetary nebula's graceful emergence. As the red giant Sun continues to evolve, it will eventually reach a point where its outer layers become unstable and are gradually shed into space. This ejection of stellar material will create a breathtaking cosmic spectacle known as a planetary nebula. These nebulae, despite their name, have no relation to planets. They are instead the remnants of dying stars, glowing clouds of gas and dust illuminated by the fading light of the stellar core. The planetary nebula formed by the Sun will be a testament to its long and eventful life. For thousands of years, this celestial shroud will grace the cosmos, its intricate patterns and vibrant colors captivating observers across interstellar distances. Within this nebula, the building blocks of future stars and planetary systems will be scattered, carrying with them the legacy of the Sun. Section 6. Fading to white. The Sun's enduring legacy. At the heart of the planetary nebula, the Sun's core will remain. Stripped of its outer layers, The core will have contracted into a white dwarf, an incredibly dense and hot stellar remnant. White dwarfs no longer generate energy through nuclear fusion. Instead, they slowly radiate away their stored heat over billions of years. As the white dwarf that was once our sun cools, it will fade in brightness, eventually becoming a black dwarf, a cold and inert celestial object. The sun's life will have come to an end, but its influence will continue to be felt. The elements forged in its core and scattered throughout the cosmos by its planetary nebula will serve as the building blocks for new generations of stars and planets, ensuring that the sun's legacy endures long after its light has faded away.